Welcome to today's class.
Welcome to my YouTube channel. Today we are going to look at the rules and formulas for solving problems on simple harmonic motion, SHM. Okay, let me start by defining simple harmonic motion. Simple harmonic motion is a to and fro motion of a body such that its acceleration is directed towards a fixed point and it is directly proportional to its displacement from that point. A body is said to undergo simple harmonic motion if 1. The acceleration is directed towards a fixed point. Secondly, that same acceleration is directly proportional to its displacement from that fixed point. Just calm down. We are going to look at the formulas and then solve calculations on simple harmonic motion. Before we look at 8 basic formulas, once you know these 8 formulas, you won't have any problem solving calculations on simple harmonic motion. But before we go to the calculation examples and how to apply these 8 formulas, these 8 tips I'm going to give you, let's look at some basic terms that you need to know. The first thing I want you to know is amplitude. We can use, is measured in meters. We can use A for it and R, just the radius for it as well. Amplitude is the maximum displacement of a body from the equilibrium position. Then the next thing I want you to know is period, represented by capital letter T. Period is the time taken to complete one cycle. Therefore, period is time taken all over number of oscillations. Period T is equal to time taken all over the number of oscillations. Then the last term I want you to know before we go to the formulas is the frequency. Frequency is the number of oscillations completed per second. So frequency is N over small letter n over T. It is measured in hertz. Now let's look at the formulas I want you to know before we look at calculation examples. The number 1 formula I want you to note is total number of angle turned all over time taken. Please note this as the first thing you need to know. Then the second thing I want you to note is that is also equal to 2 pi f. Then the next thing I want you to note is that this is the relationship between this linear velocity and angular frequency. If you see it like this, is also the same thing. V is equal to omega A, omega R. These are in meters. You can use any of them. Now let's look at the fourth point I want you to note is that period, the period T is equal to 2 pi over omega. Please note this. It is very, very important. And remember that the relationship between T is equal to 1 over F. So F is also 1 over T and T is 1 over F. With this in mind, we can have the fifth formula as frequency is equal to omega over 2 pi. That's inverse of this. Please note all this. If you watch, if you cross multiply over 1, omega is 2 pi f, you will arrive back at the number 2. So just note these things. Let it be in your mind. Then the sixth formula I want you to note is angular, the relationship between angular acceleration and linear acceleration. Linear acceleration is equal to r angular acceleration. Also, note that angular acceleration is omega square of the times the amplitude. Remember, you can use omega square r. Please write down all those formulas. Write them down, memorize them, and note them. For this formula, in a situation where there is displacement from the center, let's say x, we can have it, the last one, that v is equal to omega square root of a square minus x square, where x is that, where x is that displacement of object from the center of motion measured in rad per seconds. The angle turned theta is measured in rad. A or R is the amplitude or radius. You can use any of them. F is the frequency in hertz. F is the frequency in hertz. Angular acceleration, this is the angular acceleration in rad per seconds. Then we have linear acceleration. Linear acceleration is in meter per second squared. T is time in seconds and V is linear velocity. Linear velocity in meter per seconds. And finally, T is the period measured in seconds. 360 degrees is equal to 2 pi rad. Very, very important. I want you to note it and have it in your mind. So let's go straight to the calculation example. Let's start with the first example. The period of oscillation of a particle executing simple harmonic motion is 4 pi seconds. If the amplitude of oscillation is 3 meters, calculate the maximum speed of the particle. In solving this problem, let's write out all the parameters we are given. Giving T is giving us 4 pi seconds. R is giving us 3 meters. We are looking for the maximum speed, that's the velocity of the particle. Write out all the parameters you're given. Now ask yourself, which formula are we going to apply? Remember this formula that T is equal to 2 pi over omega. Okay, with that, we know that omega is 2 pi over t. Remember, interchange this. You have it to be 2 pi over t. So let's get our omega first. Our omega is 2 pi. T is giving us 4 pi seconds. 4 pi seconds. So if we go on and cancel, we are going to have it to be half, which is 0.5 per seconds. This one is in seconds, that's why we have 0.5 per seconds. Now that we have gotten this, we can now apply the formula. Please write the formula so that you will get mark for the formula and then substitute. R is 3, omega is 0.5. We'll have our final answer to be 1.5 meter per second. Number 2 example, a body moving with simple harmonic motion in a straight line has velocity v and acceleration a. When the instantaneous displacement x in centimeters from its maximum position is given by x is equal to 2.5 sine 0.4 pi t, where t is in seconds. Determine the magnitude of the maximum velocity I acceleration, the maximum acceleration. Okay, let's write out everything we have. Remember, we are giving x is equal to 2.5 sine 0.4 pi t. We'll compare this with this general equation. So let's compare it so that we can pick out some things that we need. Remember that this plate is equal to A. Therefore, amplitude is 2.5 cm. Remember, the question set is x in cm. Let's go ahead and convert it to meters. Divide by 100 and have 0.025 meters. So we have gotten the amplitude. Now t is equal to t, then this is equal to 0.4 pi. We'll pick out that angular frequency is 0.4 pi. So this is how you handle questions like this in rad per seconds. So what are we looking for? I said we should find the maximum velocity. With this, we are going to use this formula. You see how easy the question is. But if you see it with the long statement, you think it's very difficult. It is not. Just tackle it step by step, bit by bit. You will see that it's not hard. So we have 0.4 pi times 0.025. That will give us our final answer. Remember, pi is 3.142. Put in everything. 0.4 times 3.142 times 0.025. So that our final answer will be 3.14 times 10 raised to power minus 2 meter per second. Now let's do the acceleration. We are looking for the acceleration. A. Acceleration is omega square amplitude. So let's put in our values. We have omega already at 0.4 pi all squared times 0.025. So that we have our final answer as 3.95 times 10 raised to power 2 meter per second square. Hope you enjoyed this video. Please watch out for energy in simple harmonic motion. I don't want the video to be too long, so I'm going to do another class on energy in simple harmonic motion. Do well to like this video, share it to your friends, subscribe to this channel, and turn your bell notifications as we keep simplifying physics on this channel. Join your Digitech Academy. Thank you. Do well to follow us on Facebook, on Instagram at Join Your Digitech Academy. Thank you.